All right, we're going to move on now with the final part, or the last section or part of this unit dealing with angles. We're going to talk about adjacent and vertical angles and also complementary and supplementary angles. We've already spoken a little bit about adjacent angles. We've talked about adjacent angles being angles that share a common side. They're side by side. They're your next door neighbors. So what we're going to do now is kind of go on from there and talk a little bit more about adjacent angles, vertical angles, and then complementary and supplementary angles. As we go through this video, you're going to notice it kind of goes back and forth between the two between these different types of angles because of how closely related they are with each other. So our central question is, how do I apply equations to determine the measure of an angle? So if you will copy this down, please. And then we're going to start here, naming and identifying angles. Now, I don't need you to copy down everything, but I do want you to copy down several things. So if you'll first of all copy down that part, naming and identifying angles. Two angles are vertical angles if they are opposite angles formed by the intersection of two lines. And as we know, vertical angles are congruent and they have the same measure. So over here, we have this example. So I do want you to copy down this example. We have these two lines that intersect. When these two lines intersect, four angles are formed. And you can see here they're labeled 1, 2, 3, and 4. When they intersect each other, angle 1 is across from angle 3. Angle 2 is across from angle 4. So that means those pairs are vertical angles. 1 and 3 are vertical, 2 and 4 are vertical. And what they are, since they're vertical, and since we said over here, they're equal. Angle 1 is equal to angle 3. Angle 2 is equal to angle 4. So those are vertical angles. And if you think about it, some students in the past, they've liked the fact that vertical starts with V. And if you think about it, when you have vertical angles, they form that V right there. So opposite sides of each other are vertical, and vertical angles are equal. So let me go back here and I'll highlight that again. Okay, you should already have in your notes the information at the bottom, adjacent angles. Adjacent angles, they share a common vertex, a common side, and they do not overlap. The one thing you may want to copy down here that I did not have you copy down when we went over it is that they do not overlap. Even though I mentioned it, I didn't have you copy it down. All right, so what we're going to work with here is finding what we call missing measures. You can use your knowledge of vertical and adjacent angles to find the value of a missing measure. So what we want to figure out is, what is the value of x? So I do want you to copy this down. I do want you to copy the example down. The value of x. So we've already talked about equations. We've talked about how we solve for x, inverse operations. That is what we're going to do here. So if we look at this example here, we know that angles A and C are vertical, and we know that angles B and D are vertical. A and C are equal angles. B and D are equal angles because they're vertical. So wouldn't it make sense that if B and D are vertical, that angle B equals angle D? All right, so those are equal. So angle B, as we know, is equal to 3x minus 10. Angle D is equal to 50. So I can set my equation up like that. And now all I'm going to do is I'm going to go through the process, same as we deal with equations and inequalities. We take care of multiplication, adding and subtracting first, and then multiplying and dividing. So what I'm going to do here is I'm going to add 10. I'm going to add 10 to the other side. That cancels out, so I bring down 3x. 50 plus 10 is 60. Divide each side by 3. And that gives me x equals 20. All right, so I can check my work here. So if I know x equals 20, I can do 3 times 20 is 60. 60 minus 10 is 50. So if I substitute in that 20 for x for angle B, 3 times 20 is 60. 60 minus 10 equals 50. So and my pen's not going to work. All right, so what I can do for value of letter Y, I can do the same exact thing. So what we're going to do here is, let me erase this part. All right, so we know angle A is equal to angle C. Angle A is 2y plus 2 equals 130. All right, solve the equation. I subtract 2. That cancels out. That leaves 2y equals 128. All right, I now have 2y, so I cancel out by dividing by 2. And that leaves me y equals 64. So y equals 64. And I can check my work. I can substitute 2 times 64. 2 times 64 is 128. 128 plus 2 gives you 30. So that shows that this angle A and angle C are the same value. So as you can see here, I've applied the use of equations to figure out the missing value that pertains to the angle measure. So kind of like what we did with some other angles. So you're just applying the equations. All right, so let's move on. Let's now look at these pairs of angles. What are complementary angles? So we have adjacent angles, side by side. We have vertical angles that are across from each other. Let's now move on to the next type of angles we're going to have to apply equations to. And these are called complementary angles. Complementary angles are angles that add up to equal 90 degrees. So complementary angles have a sum of 90 degrees. So if you look over here at this example, I have this right angle, as we can see based on that little square. Then I've divided this right angle up into two smaller angles. And I have this one is 25 degrees, that one is 65 degrees. This angle that measures 25 degrees, when added to the measure of the other angle, which is 65, they give you 90 degrees. So 25 and 60 gives you 90. So that means that these two angles that measure 25 and 65, those are complementary because they add up to equal 90 degrees. All right, so let's now move on to supplementary. Supplementary, very similar to complementary, with the exception of supplementary angles are angles who add up or have a total measure of 180 degrees. All right, we all know that a straight line is 180 degrees. So if I take this straight line and I have it divided up into two different angles, this smaller one is 45. Oops, let me change that. The smaller one is 45 and the bigger one is 135. So if I add 45 plus 135, that gives you a total of 180 degrees. So we have two types of angles now. One is complementary that adds up to 90 degrees. One is supplementary that adds up to 180 degrees. All right, so let's look at this. Let's identify each pair of angles as complementary and supplementary. All right, this one right here is 25 degrees. This one right here is 65 degrees. And as you'll notice, these are the same values that I have right up here. Those add up together to give you 90 degrees. So these two would be complementary because they add up to 90 degrees. All right, let's look here. We have two lines that intersect. We have angles 1 and 3. As we already know, we just talked about vertical angles. They're vertical. We have angles 2 and 4 that are across from each other. They're vertical. All right, but what I want to look at is, let's just pick one of these straight lines. So let's look at this one right here. Angle 1 and angle 2. If I take angle 1 and I add it together with angle 2, it's going to form that straight line because here's angle 2 and here's angle 1. If they form a straight line, we all know a straight line is 180 degrees, so that means that those two angles would be supplementary. All right, complementary is 90, supplementary is 180. All right, here's a little trick. I had a student first several years teaching. Said, okay, the way I remember complementary and supplementary is if I take the first letter in the word complementary, which is a C, and I draw a line straight down, it forms a 9 for 90. So 90 equals complementary. And if I do the same thing with the S, connect the two sides with a line or the two endpoints, that gives me 8 for 180, which is supplementary. So if that little trick helps you, go for it. All right, it says draw an adjacent complement for each angle. What is the measure of each angle? Let's don't worry about drawing it, but let's just figure out what would be the complement for each of them. We know complementary is 90 degrees, so if this is 80, all I have to do is figure out, okay, if I need to get 90 degrees, 90 minus 80, most of you can do this in your head, that gives you 10. So my complement would be a 10-degree angle. All right, letter B. We have a 90-degree angle, which would be complementary. If I subtract the one we have, which is 30, that means our complement to it would be 60 degrees, or a 60-degree angle. All right, this one right here, we know we're trying to get 90 degrees again. We have an angle that's 45. So if I subtract 90 minus 45, that would give us our complement, which gives you 45 degrees. So that's how we would find the complement for each one. That's very simple. All right, let's now look for the one that would be supplementary to it. All right, supplementary, as we all know, is 180 degrees. So we want to figure out what we would have to add to each of these to get 180 degrees. All right, this one's 50. We know supplementary has to add up to 180. So if I just subtract 180 minus 50, that gives us an angle of 130 degrees, which would be the supplement. All right, we have one here, 165. So if I just subtract 180 minus 165, that gives us an angle of 15 degrees, which would be the supplement. And then this one right here, we don't have an angle measure, but we do have this little square here. And as we all know, that square represents an angle that is 90 degrees. So we know that we're trying to get supplementary angles, which means we're trying to get 180 degrees. So if I take 180 minus the angle I have of 90, that gives us our supplement, which would be 90 degrees. All right, I want you to do this one. So y'all try this one.